Hi, everybody. Awesome. Cool. Thanks, everybody, for joining us today. So this session is entitled Running Enterprise Workloads in the Cloud. So I'm Jeff Spazzetti. I'm actually a product manager at Hortonworks, and I'm joined by Attila Kanto, who is a principal engineer at Hortonworks as well. So we work together on some of our cloud solutions, and today we're going to talk about a specific one, Cloudbreak, and kind of walk you through what that is, what it does, the easy stuff, the more advanced stuff, talk about where it's going and how we see this applying to enterprise workloads for big data, and then also talking about some lessons we've learned, kind of putting the tech together, using cloud over the past 4 or 5 years, and seeing how we were able to put the product together, and kind of sharing some things that we've learned and you don't have to relearn, which should be good, and then kind of wrap it up from there. So kind of start off with a little bit of an introduction, just really, we'll try to, this is the standard story when we've talked about cloud over the past couple years. So I'm kind of going to leave out the first 2 boxes. We all get it, consumption-based way to get resources. You can get them faster than you ever could in your data center, and the scale is always more than any data center can hold. But the big things that we've learned about cloud, especially when it comes to big data, are these 2 right pillars. One is the ephemerality that's available to you. So the idea that you can actually go and do things for the exact amount of time you need to do them, and spin up stuff on demand, and then spin them down when you're done. And that is something that is really important and critical and available in cloud that people have kind of been always looking for from their data center infrastructure, but cloud just makes it part of their world. And this really changes the game when it comes to big data workloads, which is ephemerality, which leads to the 4th box, which is agility. So if I can get things when I need them, use only what I need when I want to use it, that gives me a lot more agility with what I can get done. So ultimately, ephemerality kind of changes the game for big data workloads, but then it will power the agility to do what you want when you want with what you want. And so when we look at Cloudbreak as a technology, it's an open source project that helps you go and launch big data workloads on clouds. It will help you harness that agility and take advantage of that agility for running those workloads. So with Cloudbreak, you can actually sit there and point it to your cloud of choice, AWS, Azure, Google, and it will launch a workload environment for you that you can spin up, do the work you need, and then spin it down from there. And in this case here, we're going to be talking specifically about workloads that are based around Hortonworks platforms, like Data Platform to run EDW workloads, or Spark and Data Science workloads, or HDF, which are more around flow management and streaming. But ultimately, what you can do with Cloudbreak is get a way to spin up these environments across these different cloud providers to get your workloads that are ready to run. It gives you a lot of flexibility when it comes to saying how you actually want that environment to look like. So it will be easy to get started, but then ultimately give you the choices to be able to go and say, I want it this way, so a lot of flexibility. It gives you a lot of different configuration options, and big thing is it gives you a lot of different security options. So every cloud provider out there has a lot of the building blocks for security. It's really up to you to use them correctly. Cloudbreak tries to help to be a lot more prescriptive with that use. It also sits there and says, standing in front of something and pushing buttons is great, but ultimately, if you have agility, you want to be able to go and automate. So Cloudbreak has a DevOps mindset to be able to say, how do I get it set up? How do I get it running? And how do I repeat it again and again and again? So it should be simple to automate. And then let's take advantage of all the availability of resources in the cloud so that I can actually go and get more resources if I need it, or give back resources when I'm done so it can help scale. And then ultimately, you're running in a cloud environment. And we know in a cloud platform, there are certain things that are just there that just might not be available in your data center. Let's try to make sure we make it easier to integrate with those things. So we'll talk a little bit about that, especially when it comes to cloud storage. So at the highest level, picture of Cloudbreak we're talking about here is deploy environments for workloads on any of the public clouds that are out there, AWS, Azure, Google. It also supports a private cloud option to deploy on your own OpenStack, for example. It will help you go and handle getting resources, spinning up workload clusters on those resources, and then scaling those out. And it also tries to help give you some guidance and prescription on how you can actually secure these workloads all the way from the network side all the way to inside the cluster, and enabling really kind of advanced security concepts like Kerberos. So there's a lot of building blocks that kind of get you there. There's things about how do we talk to your cloud, what should the workload actually look like, and how do we do scaling, and so many different things that try to make it simple. Then can we also make it more prescriptive? And then how do we set up security? Not going through every single one of these in detail with slides, but let's actually look at the product and hit some of the key concepts to start. So I'll first confirm I'm still on VPN to make sure there's no hiccups here. So I'm actually using a hosted instead of Cloudbreak. So just so everyone's aware, so Cloudbreak is delivered. You can stand it up and run it in your own environment, so in your own cloud, and then point it to your own cloud environments. We at Hortonworks actually like to run it internally as a service to our internal customers who want to try out things with the tech. So it's good for us, meaning we get experience running Cloudbreak and seeing it firsthand with our users, and we try to push that right back into the product. But that's what I'm using here. I'm using our internal Cloudbreak server. And some of the building blocks that I had mentioned earlier, I just want to highlight here. So when you come into Cloudbreak, you really will end up starting with, I need to talk to a cloud provider. So you'll configure Cloudbreak with cloud credentials, so it can go talk to your provider, and it can support talking to Azure, AWS, Google, OpenStack. And the configuration experience, really, we tried to make it prescriptive for folks, so that if you go and do something like, for example, against AWS, we give you a couple choices of how we can talk to your AWS environment. So whether you're going to use role-based authentication or key-based authentication, we try to blend right into the experience itself. What does this mean when you choose key-based authentication? We walk you through how do I make sure my environment's ready for this type of setup? And then ultimately, you can save those credentials, so now Cloudbreak is at least ready to talk to your cloud provider. That's step one, basic building block. Step two is I want to go and use resources from that cloud to go spin up workload clusters. And out of the box, to give you an idea, we provide what's called blueprints. Anyone familiar with Ambari Blueprints? All right, a couple folks. So this was something that actually emerged a few years ago out of the Apache Ambari project, kind of like a declarative way to say, put a cluster together like this. I want it to have these services, I want it laid out this way, I want it configured this way. And that's a really key piece of tech that allows us to use that same language so that we can go and describe workload clusters to people. So out of the box, we do give you some getting started experiences. So you bring your own cloud credentials. We in the box provide it 4 blueprints for common type of workloads you'll run. We'll skip the first one right now, but the second, third, and fourth, a data science type workload where I plan on running Spark applications with a Zeppelin notebook in front of it. The second is for analytics. I want a workload that's going to be accessed via JDBC to do SQL work, and Hive LLAP will power that. And the third is traditional ETL, run Hive, run Spark to just get some work done. These are at least great ways to get started, but ultimately people go and use this as a model for their own type of blueprints, or just bring their own, because you can always create a blueprint here and upload it. But together with cloud credentials and the blueprints out of the box, I'm actually ready to go spin up an environment to get some work done. So I'll walk you through the wizard here, and again, watching a UI is awesome. All of this is available from a CLI, so it's easy to automate and integrate with it into any experience you want to have there. But basically, when it comes to creating a cluster that's ready to run work, we try to take the approach of let's try to make it easy to get started and ask the minimal amount of questions, but then always have an advanced option so that you can choose more options if you need to, and especially when you're ready to. So under the general configuration basic, I want to say that I want to spin up a new cluster into AWS, into this location, and I plan on having it actually do some data science work. So in the simplest case, I give the cluster a name. It's gone and analyzed that blueprint that came out of the box and said, well, what should I use for resources from the cloud? So it's made some suggestions here. It thinks, hey, you should have one master node and look like this. You should have at least one worker node and look like that. And hey, guess what? No compute right now. Your kind of choice to change that. In terms of prescription for security, it will sit here and say, I know you're doing this in the cloud. And the first layer of security is how do people access these resources in the cluster over a network. So Cloudbreak knows this is happening, and this is a really common thing that people just end up launching things in the cloud, don't realize they're launching it and having public IPs and public DNS kind of show up, and you increase an attack surface area. So what we've done and said, Cloudbreak should help you avoid this, because the best practice is to wrap your cluster in Knox, and let's make sure that we make that easy on you. So we know what you're spinning up here. It's analyzed the blueprint. It knows Ambari's in the cluster. It also knows Hive is in the cluster. Let me go wrap the cluster in a gateway so that I can have a single point of access. And we'll go and do that for you. From a network perspective, simple case to get started. We'll go into your cloud environment and create a new network and subnet. We'll be prescriptive with setting up security groups. This is a great way to get started, but ultimately you'll tweak these depending on other access points you want to have. The basics really are around, let's make sure Cloudbreak can talk to the master node in the cluster, and it will do that over this port. It's your choice whether to configure access to the boxes directly via SSH, but really since we decided to use the gateway and we left that option checked by default, it will make the main access point 8443. So that if I want to get to Ambari or Hive that I enabled in the previous screen, I'll go to this point. So this is an easy way to get started, but ultimately people tweak this, use their own network, and use their own security groups. Then the last thing is saying, well, how do you actually want to go authenticate to the cluster? And in the most basic case, we're really talking about just setting up this cluster for a single user. Because ultimately, it's just going to do some work and then go away. We'll talk about more advanced scenarios where we bring in LDAP and have other means of authentication. But the simplest case is, let me set up the cluster for a single user that you're ready to submit work towards. And then ultimately, you create cluster. You click this button. You'll go out to the cloud provider, spin up the resources it needs in terms of machines, set up the network, and then go lay down the software and configure it just like you asked. And this is a great way to kind of look at the UI. And I mentioned the CLI a couple times. But we also bake that experience into the UI as well, because you can use this as a learning tool and then ultimately say, well, this is what I want and I want to repeat it. We give you the ability to grab some JSON that's ready to be used for you to automate against. So in this case here, I've actually gone and created clusters. And the one cluster I have here actually is running Hive LLAP. I have access to the Ambari that's running in there. I've also configured the gateway. And I made sure Hive is accessible through that gateway, and I know how to access it via JDBC. So I've wrapped it in Knox. I made Ambari and Hive accessible, and I have a way to go do that. I can actually go and do some things to this cluster, which I might want to go and resize the cluster. So a scenario here is I sit there and say, I know I want more power in this cluster, so I actually go do a manual resize. So in this case here, it goes and looks at the cluster, how I had defined it, do I want to go add nodes, this type of node, and it will go and execute that for you. So this is really kind of a manual case, and again, this can be called from the CLI to go add nodes to a cluster, as well as remove nodes from a cluster. There's a more advanced scenario where since Cloudbreak knows about the resources or how to talk to your cloud provider to get resources, and it knows about what's happening in the cluster, a really powerful feature is auto-scaling. So you can sit there and for this workload environment, you can say, I want you to watch this cluster, and if you see some things happening, I want you to take action. And you can say, watch certain metrics, and if this metric hits, go and add nodes to the cluster. Once that cools down, take the nodes away. You can also set it up to be time-based. So it could be very well something that you say, every night I want to make sure I add 5 nodes. Or I want every morning 5 nodes, and then every night take them back down. So you can actually set up those things. Since Cloudbreak knows about the resources and the cluster, it can go and handle these things seamlessly for you. So some of the building blocks we went through here, that's kind of the basic demo that we'll start with. But some of the building blocks we hit, cloud credentials, once my screen shows up. There we go. Ambari Blueprints, auto-scaling, network, and gateway. So there are some more advanced topics I wanted to make sure we hit. And we'll kind of give you a walkthrough of those so you kind of see some of the more advanced things that you're going to want to do in cloud. And those cover custom images, a more flexible way of doing blueprints for reuse, and now we'll hit on authentication. How do we help set up integration with cloud storage, be really prescriptive in those environments, and what does Kerberos mean? So let's hit each one of these. So I'll kind of hit a slide, hit that feature, then show it to you type thing. The scenario here is custom images. So what I did actually with Cloudbreak was I went and would spin up a cluster. I picked the instance size. I said what I wanted to be configured, how I wanted it configured. It went and did that using an image that Cloudbreak knows about, which is great for everybody to get started. But 9 out of 10 enterprises have their own way of saying, this is the image I trust. And when I make a machine, I want it to look this way. So I want an image I trust. I don't want the rel you gave me. I want the rel my infrastructure team gave me. So Cloudbreak gives you the ability to say, use this image instead of the ones out of the box. Out of the box is great for first-time user. The real experience is being able to say, can I use a custom image? So what Cloudbreak actually does isn't just say, let me just go and set a different image to use. It actually gives you the ability to go create the custom image, make the image available to Cloudbreak, and then use it. And it has a pretty advanced experience in terms of doing that with a lot of flexibility, so that we know companies also go through life cycles with their images, and we want to make that all available to people. So the scenario is, out of the box, by default, Cloudbreak specifies what images should it use for different configurations of software and different operating systems. You can actually go and register your own image catalog, where you can say, I want this image catalog to be for production-based images using my own rel. So you can actually register that catalog here. And then you can also have a QA environment type image catalog. You could have a test environment catalog. You can have many different catalogs available. So once you have all these different catalogs available, you can actually change one thing when it comes to spinning up your cluster. So if I went and wanted to go try to make my new cluster again, once AWS loads up for me here. We're still on the VPN. Let's see. I'm going to do a reload here. Yep. The demo. We're still on. Sorry, folks. All right, something's reloading. That's probably better. Back to where we started. All right, my new cluster. So we're actually back to custom images. We're going to go and take a look at how I actually choose from those custom images. So here I am. I actually have still the basic setup, general configuration. I actually switched to advanced. And on the next step, it gives me a choice of, well, what do you specifically want me to spin up? So I could choose from the catalog that's still there by default, or I can add other catalogs to it. I can go and say what type of image, if I have different operating systems there. I could even say what specific version of HTTP or HDF do I want? And where should I get that software? Should I use those public repos or my own internal type repos type thing? So you get a lot of flexibility here with choosing custom images, which is a typical enterprise type requirement. So we make all that possible with Cloudbreak. Another scenario to take a look at is Kerberos. So we can do entire talks on Kerberos and what it means inside a cluster, but at the highest level for Hadoop and the ecosystem components, Kerberos is a way to have strong authentication inside of the system, as well as establishing user identity when they're using the system. And it's based on having Kerberos infrastructure and having the components know how to talk Kerberos between each other, as well as users that show up to be able to have Kerberos enforced. The scenario is Ambari has for years helped simplify the setup of Kerberos in these types of environments. And Cloudbreak really takes advantage of that, but we try to be a little bit more prescriptive and helpful since we know what you're trying to do in the cloud. So in terms of Kerberos support, we'll keep going along the lines of this cluster that's an advanced setup. We know we see machines. We see a few other choices for folks here. We'll skip through networking, and we'll get to the security tab. Here, actually, under advanced, I have the option to enable Kerberos in the cluster. And the advanced scenario here, we know 9 out of 10 for enterprises, they have their own Kerberos infrastructure. Active Directory being the most popular, or they have their own infrastructure that they've stood up with MIT KDC or similar. So that's the default experience. You can bring your environment, and you basically make sure Cloudbreak knows that you know what you're going to do here. And then we can go and help you set up the environment to talk to that Kerberos infrastructure. We make some assumptions for you to say, do you want me to go talk to MIT KDC or Active Directory? This is the information I need, and that type of thing, so that when we go and lay down the cluster, we make sure it talks to all that infrastructure properly. But this is great once people actually know what they want from Kerberos. They've talked about it with their security teams, and they know all those moving parts. But we also wanted to make sure Cloudbreak can help people get started in general. We provided a test KDC option here, where we'll put in a little test KDC, and we'll configure the cluster for Kerberos so that we'll end up using that bit there too. So it really helps even you not just get the cluster spun up and configured with Kerberos. You can get more familiar with how Kerberos works and how your users would interact with it, because we can give you this test environment as well. So 9 out of 10 people use Kerberos. They'll bring their own. But when we baked all that in and made that possible inside of Cloudbreak, but we also give you a test option there as well. So another more advanced area I want to talk about here, it's what we call dynamic blueprints. So it's awesome. You can bring your own blueprint. You can upload it. You can go and tweak it and do all this magic. But there's just common things we know you want to use across blueprints. And those common things really speak to 2 main areas. When you set up a cluster, you want it to go and talk to an external database, because there's just some components in a cluster that need external configurations. So Hive Metastore needs a database. Ranger needs a database, and other things like that. Also, you often are going to set up your users in an external LDAP or Active Directory. So you need to go and say, make sure when you configure this cluster, configure it with authentication to that external source. So dynamic blueprints helps to make that a lot easier for you. Because typically what you'd have to do is go and figure out all the configurations and then have blueprints for each different possible permutation. We can actually take out a lot of that guesswork for you. So if I go back into Cloudbreak, in this environment here, under external sources, I can actually register my corporate LDAP or an external LDAP for authentication. And in this case here, I've gone and said, this is how you would go talk to my LDAP and what I need to have set up there. Similarly, I've done that for databases. So I've gone and registered databases for Hive that could be used for Ranger and other different choices here as well. So do you want me to go talk to Druid? Do you want me to have things for Superset or any other custom thing possible? And those external databases can be Postgres, Oracle, MySQL, whatever you want them to be. Then the reuse really comes into play when it's time to go and spin up a cluster. So in the simplest case, back to where we were before, I am going to go spin up a cluster and choose some default settings. What I actually want to do here is say, when I spin up this cluster that's going to go and run Spark workloads, let me also configure that cluster to work with this LDAP for users. Real common scenario for folks. And we know how to take your blueprint, that's your base blueprint for Spark and Zeppelin, and now we know how to inject all the LDAP for authentication. Similarly, we would say, make sure the Hive that's in that cluster uses that database, and make sure the Ranger is in that cluster uses that database. So this really helps with reuse and should help you go and have a single blueprint, different possible configs for external sources, and we can put the 2 together for you when we go launch your cluster. So there are 2 more areas I wanted to hit on the advanced scenario option. Actually, there's one more area, cloud storage, and then we'll get to kind of a bigger ticket item. So I mentioned earlier that when it comes to spinning up a cluster and you're working in a cloud environment, a very common thing and a very good pattern, especially with the option now to have ephemeral type workloads, is your data is in cloud object storage. So you have data that's landing in S3 in the AWS world. You have it in ADLS or WASB in the Azure world, or in Google Cloud Storage in the Google world. So you want to make sure when you spin up this cluster, it's configured to go talk to those things. And again, this is something we don't want to have you go figure out. We know you're launching in a cloud environment. Let's help you do it. So since I'm launching this cluster into AWS's environment, I can actually go and say, let me make sure I configure that cluster to be able to talk to S3. So I'm able to go and say, yes, when I spin up that cluster, you'll be able to go set up this, leverage this role so that it will go and talk to S3 under that role. So this kind of takes a lot of the guesswork out when it comes to configuring the cluster to go talk to cloud storage. So we try to be a lot more prescriptive here. We also know there are very common things you're going to want to set up in your cluster when you're talking to cloud storage. And so we give you another option here, advanced, to say, well, I plan on actually having any Hive activity that happens always be stored to this S3 bucket. So I can go set up a data warehouse. I can set up the Hive warehouse to use S3 storage by default, no matter what. So we try to be prescriptive there. So it actually analyzes your blueprint and will check for if you have Hive, should I set the Hive warehouse? If you have Ranger, should I set the audit log directory to be cloud storage? And things like that. So this is really an important area when it comes to prescription. We know you're running in a cloud environment. We know you want to integrate with cloud storage. Let's go take some of the guesswork out. The power's there in the platforms when it comes to Hortonworks Data Platform and Hortonworks Data Flow. Let's go and take some of that guesswork out. So some building blocks, some more advanced features. There's one area that I wanted to spend some time on, and we really think this starts coming home as people really start taking advantage of ephemeral workloads in the cloud. And we call this a data lake, and really the idea of sharing services between a data lake. So Cloudbreak helps you put this together. Because the idea here is, if you're there and you're going to go run ephemeral workloads, your workloads will come and go, but there's a common need for always having your Hive schema available. And you want to make sure that if you've set up security policies around that Hive schema, or you're going to control access to that Hive data, that schema is always available, the authorization policies are always there, and audit's always captured there. So we looked at it and said, as people start thinking about ephemeral workloads, they can do very basic stuff that Cloudbreak will help you set up. So they can go and get their infrastructure spun up, talk to cloud storage, we'll wrap it in a gateway, and they'll just run. And every time they spin up a job, they set up whatever they need in terms of schema, authorization, or other things. A more advanced scenario is they might reuse the Hive metastore and always point to the same database, so that's fine as well. But a really common scenario is I want to actually do a lot more than just schema. I want to make sure that my clusters get spun up, that are set up for multiple users, have the same security policies, and also audit to Ranger. So there's a lot of building blocks that go into this. The Hive metastore, Ranger for security policies and audit, the directory for LDAP, as well as the Knox gateway. You kind of put all these things together there, and you take them, and you say, if I have all of this available schema, policies, cloud storage, and my users, I actually should be able to spin up a central data lake. And then when I go and actually want to do some work with Hive LLAP or Spark or anything else, all I really do is make sure I spin up my cluster to do that work and inherit all of that. So it should inherit the security policies and the schema from that data lake. I do my work, it audits to that location, and I tear it down. So this is a key enabler for us really being able to take advantage of the ephemerality that cloud affords. So the last thing I want to show is kind of how this comes together in Cloudbreak, and then we'll switch over and talk about some of our lessons learned. So I had mentioned earlier before when I showed blueprints. Let's make sure. Oh, I've lost it again. Let's go back on the VPN one more time. We're back in. Good. There is this data lake ready blueprint. this becomes that central place for Ranger and Hive Metastore schema. And I can actually go and spin up that data lake. And that data lake is the smallest amount of resources I need to have the Hive Metastore and have the schema available. So I can go and access the Ambari from there, the Ranger from there, set up policies around there, and manage my Hive schema from there. And then when it comes time to actually go do some work, where I want to go and say, give me JDBC access to data, and I want to go run some queries, I can actually go spin up a cluster, and I can make sure it attaches to that to inherit all that information. So it's really kind of a new approach to taking advantage of ephemerality of cloud, and Cloudbreak tries to make it prescriptive for you. So this is a new area of Cloudbreak that'd be great for people to try out and get some feedback on, but I at least wanted to introduce the concepts here. So that was kind of all the stuff I had to kind of get us here, but we learned a lot along the way, and I'm going to hand it over to Attila to walk through that.
Thanks, Jeff. So in the next few minutes, we are going to talk about the 4 most important topics what everybody is worried about when deploying HDP into the cloud. These topics are the performance, costs, reliability, and security. So when we are talking about cloud deployment, it's very hard to speak separately about performance and costs. They are somehow tied together. And usually there is delicate balance between these two things. So therefore, I'm not attempting to speak about these 2 things separately. So the first 2 slides will be about performance and cost. So Cloudbreak offers a uniform API for all major cloud providers like Google Cloud, AWS, and Azure. And also for private cloud deployments, also for OpenStack. So we can do that because all of the cloud providers have some notion of compute, virtualized network, storage volumes, attached volumes, security groups, etc. So they kind of look like the same. But this basically might cause the false understanding that, okay, I don't need to understand my provider because Cloudbreak will do the provisioning for you, and basically I don't need to understand anything from anything how the provider works. But that's not true because providers are also different. They have a difference in performance. They have different performance characteristics. They have different cloud connector architecture. And for example, some of the providers are supporting connector architecture, which is supporting eventual consistency. Another is supporting strong consistency, which can have impact on your workload. And of course, there are differences also in functionality. For example, some of the providers are supporting such advanced features, like you can interconnect virtualized networks, which are not even in the same regions. So the 2 main contributors that are responsible for the costings and performances are the compute and storage resources in the cloud. And as a rule of thumb, you need to pick the right instance type for your workload. Every cloud provider is supporting general purpose, compute optimized, memory optimized, and storage optimized machines or virtual machines. But that's as we learned, that's usually not enough because there is also an important thing like network bandwidth. So not all of the providers, not all of the virtual machines are having the same bandwidth, which means that smaller instances can have only 1G interconnectivity, which means that even if you have picked the right machine for your workload might run slow because you are saturating the network bandwidth with, let's say, with the HDFS replication. In case of storage, of course, you have multiple choices, and they are they have impact on speed, reliability, and cost as well. If you are taking, let's say, an on-prem deployment, and if you would like to replicate the same thing in the cloud, then probably you would go to the direction of the aggregated storage, which means that every instance is coming with some kind of aggregated or ephemeral storage, which are fixed size and usually fixed number, which means that you are basically you are tight coupling your compute instance with available storage on the machines. And if you would like to have more flexibility, then you need to go down a different path, which means that disaggregating the storage and the compute nodes. And here you have multiple options. One is using the block storage, which is attached to the virtual machines, and put an HDFS on that one. On another recently emerging pattern is to use the cloud object stores using the connector architectures. As you have seen, there are a lot of choices here. But what is important that in case of cloud deployments, the capacity planning is fundamentally different than in on-prem. Of course, the workload type is usually determines the instance type, what you would like to pick. For example, if you have a machine learning type of workload, then probably you are going to pick some instance which has GPU accelerator in it. Or if you have, let's say, an interactive workload, then probably you would like to have some kind of instance which has high memory in it, in order to be sure that a lot of things can be go in memory and your interactive queries can run fast. But in case of cloud deployment, the fundamental difference is that experimenting is cheap. So this means that you don't really need the right instance type and right setup starting from the first minute. You can just launch a cluster, try it out some things with different VMs, different storage options, and later on, if you think that things are not going well, then you are just terminating a cluster and launching a new one with different settings. So what is important that in the cloud, unless in the cloud you can basically allocate and release resources on demand. This is not really easy to do it on-prem. And before, flexible cluster shapes and cluster size are basically must have in cloud. Therefore, in Cloudbreak development, we have invested a lot to be able to support basically different cluster topologies, different cluster sizes, etc. So in case of cloud deployment, you need to think about cluster size as a variable and not as a constant. As mentioned, that experimenting is cheap, but only in the early phases. If you are in production, then usually experimenting is not cheap, which means that it's the best practice that you need to automate everything and you need to have DevOps mentality. And no any manual configuration or fine-tuning is allowed. Manual fine-tuning is allowed in production deployment, because if you are doing that, then you lose the ability to quickly, let's say, quickly react on things. You cannot upscale, downscale your cluster, because you need to do some manual things. Every cloud provider has a notion of fault domain or availability zone, or basically just zones, which means that somehow instances running in a zone, they are geographically co-located and basically live and die together. So if there is some catastrophic event happens, then it can happen that a set of instances just disappear. So therefore, if you are setting up AJ topologies, name node AJ or resource manager AJ, it's a good start. But you need to make sure that you consider that these the standby and active resource manager or name nodes are not running in the same fault domain. This similarly also for the data nodes, where you can set up REC awareness. Of course, cloud providers are not exposing REC awareness, but you can basically use the fault domains as REC values. Another option is that if you are externalize the state, this is also a good thing. So which means that you externalize all of the files, notebooks, schemas, policies, Ambari Ranger, Hive, Metastore database, etc., which means that you can easily terminate your cluster. You don't need to go through the complex AJ setup and etc., but you can just terminate the cluster and you can launch another cluster in another availability zone pointing to the same schema, same database, same Ambari Ranger and Hive database, and you can have basically the same cluster back. And if you have some problem with performance or costs in production, that you can debug it and fix it. But if you have a problem with security, and if you have a security breach, then usually that's not going to have a good end. And so this means that if you are deploying HDP into cloud, you need to be sure that you are designing your deployment to be secure starting from the first minute. Of course, this can be solved with the layered security model, which means that you need to consider perimeter level security, enforce authentication, authorization, and data protection. Of course, Cloudbreak helps you to do that. So you have the option to deploy your cluster into a VPC or a private VPC without even external connectivity. You need to make sure that all the inbound connectivity is set up properly. You are just opening the bare minimum what is needed. Also, you can limit the outbound connectivity. Which means that all of the outbound connectivity can go through proxy, or even you can deploy cluster which has no internet connectivity at all. And also, you can have NOx in your deployment. You set up the proper cluster topology in order to make sure that every cluster interaction is going through to NOx. Also, you have the option. These options are of course available on Cloudbreak UI. Regarding authentication and authorization, it's basically the same like in on-prem world. There are not too much differences. The same concept apply, except in case of authorization, cloud providers are usually providing cloud provider-specific authorizations, which means that you can set up an EIM roles, for example, and associate it with your virtual machines. And with that, you can limit the access of that virtual machine to, let's say, to a given bucket. Regarding data protection, at rest in motion, the same rules applies like in on-prem. Additionally, that providers are allowing you to basically to set up disk encryption to make sure that your disks are encrypted. So
we have to finish the session to make room for the next one. What we'll do is
okay.
Actually, we're heading over to the Birds of the Feather, which is next door, or is it in this room? I'm not sure, but it's next door. Cloud and operations, we can continue this conversation with questions and topics and go into it. You can also visit breakouts tomorrow to kind of learn more there. But see you next door, and then we can handle some questions on that. Cool. Thanks, everybody.
Thank you.
Cheers.